channel. Now, friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with the physics class 11. That is your class 23 here, and that we had done your 22 with class in the last sessions as well. So here we had done unit 1, which is a physical world, and unit 2 is units and measurement. We are continuing with the unit 3rd, which is your units. That is your here. That is your motion in a straight line. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. In terms of it, before starting with this, we'll start discussing about relative velocity. The last we had done for the stopping distances of vehicle and the reaction time, which we had done in the form of numerical. Now coming towards relative velocity, that is the new topic which we will be discussing here. In terms of relative velocity here, that you must be familiar with the experiences of traveling in a train and being overtaking the another train moving in the same direction as you are. While the train must be traveled faster than you to be able to pass you, it does seem that slower to you than it would be in the sometimes standing on the ground and watching both the trains. In the case both the trains have the same velocity with respect to the ground, then to you the other train would seem to be not moving at all. And to understand that such observation, we know introduce the concepts of relative velocity. You have to consider two objects A and B moving uniformly with an average of velocity VA and VB in one dimension. You have say along with x-axis, and unless otherwise specified, the velocities mentioned in this chapters are measured with reference to the ground. Hello everyone, welcome to the channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics. That what we have talked about it in terms of velocity. Relative velocity we have to discuss here. You have to consider the two objects A and B that moving uniformly with the average speed of VA and VB, where in one dimension. You have to say along x-axis, and unless otherwise specified, the velocity that is mentioned in this chapter that are measured with reference to the ground. If xa 0 and xb 0 are positions of objects A and B respectively at time t equals to 0, so their position xa of t and xb of t at time t are to be given as, like that will be here, which is xa of t equals to xa plus vat. So for xb of t, it equals to xb of 0 plus bb t here. On the same way, then the displacement from object A to object B is to be given as xba of t equals to xbt minus x of at here. So that is being equals to xb0 minus xa0 plus vb minus va of t here. So for that equation, it's easily interpreted, and it tells us that as seen from object A, the object B has a velocity of VB minus VA, because the displacement from A to B that changes the steadily by an amount of VB minus VA in each unit of the time. We say that the velocity of an object B relative to object A, where VB minus VA. So for that, we'll write it down. VBA equals to VB minus VA. And similarly, the velocity of the object A relative to the object B is VAB equals to VA minus VB, that we have here. On the same day, we'll discuss those further, and that what will be helpful to us to explain, relative velocity. So we have a graphs here. First, we'll draw those graphs, and then we'll discuss about them in a detail here. So this will shows here first VBA equals to minus VAB. Okay, that's what we have. So now we go to draw the position time graph of two objects with equal velocities. So here we go. This is a graph. It will be minus 1, minus 2, 0, 1, 2, 3, 4, 5, 6, T of it. This is minus, this is 20, 40, then X. So here it will go this is for B, and from here it will be go. This is your A. They for the parallel. This is the graph which is for position time graph of two objects with equal velocities. Okay. Now we have another question, another time graph that we have. Although we discuss one by one here. Now, another one we have here is, so this is your 0, then 20, then your 40, 60, 100, 120, 140. This is what X meter. This is 0 here, 1, 2, 3, 4, 5, 6. This is for T of S. This is a graph for position time graph of two objects with unequal velocity. Showing the time of meeting. Time of meeting. So for that it will start from 0 to 10 between. It will go raise to power A. And 1 is 1 from 40. It will go here till 6. So it will intersect at 3 here, and so this is the intersection point. It will intersect at 4, not 3. So this is how this is showing the velocity that time meeting here. Now we go for another graph, that will be another important one, and that is your position time graph of two objects with velocity in opposite directions, shown the time of meeting. Another graph. This is being exceeded 0, minus 20, minus 40. This is 20, 40, 60, 80, 100, 120, then so on. Okay, this is X in meters, and here it is 1, 2, 3, 1, 2, 3, 4, and then 5, then we have your 6. Okay, this is of t of second. So for the same, it will go, this is at point B, and here it will go from 0 to 20. So it will intersect at point 1, and this is known as A. This is a graph for position time graph of two objects. Position time graph of two objects with velocities in opposite direction, with velocities of opposite direction, shown the time of meeting. Okay, now for that we consider here some special cases. If V of A, that equals to VA, and V naught minus AVA equals to 0, then from this here XB of T, that is minus XAT, equals to XG of 0 minus X of A0. Therefore, the two objects stay at constant distance and apart, and their positions time drops are straight lines parallel to each other, as shown here, that the relative velocity VAB and VBA is 0 in this case. And for another one, the another case is here that VA is greater than VB and VB minus VA is negative. So one graph is steeper than the other, they to meet at a common point. For example, like suppose VA equals to 20 meter per second and XA is of 0 is equals to 10 meter. So BB is 10 meter per second and XB of 0 equals to 40 meter. Then the time at which they meet is T equals to 4 seconds. On the same way, at the time they are both at the position XA of T and XB of T here, where that is being 70 meter, and that object overtakes object B at that time. In this case, VBA equals to 10 meter per second inverse minus 20 meter second inverse equals to minus 10 meter second inverse equals to, which is minus GAB. On the same way here, for this we'll talk about it. Suppose VA and VB are the opposite sign. For example, if the above example object A moving with 20 meter second inverse starting at XA 0 equals to 10, and object B is moving with minus 10 meter second inverse staring at XB 0 equals to 40 meter, that the object meet at here, and that will be, in this case, the magnitude of VBA and VAB, that is your 30 meter per second, and the greater than magnitude of velocity of A or that of B. If the object under considerations are two trains, then the person here for a person sitting on either the two, and the other train seems to be very fast, so that our valid even in a VA and VB, that represents the instantaneous velocity, which we had done in the last classes as well. Now coming towards one of the question that has been the important one, the important question of course, and that has been the last question of the session as well. So here we go for the same, and that is the 9th question of the session that we are going to solve. The question is, two parallel rail tracks runs north-south. Train A moves north with the speed of 54 km per hour, and a train B moves south with a speed of 90 km per hour. What is the you have to find out. There are many questions that have been asked. Velocity of B with respect to A, velocity of ground with respect to B, and velocity of a monkey running on a roof of the train A against its motion with the velocity of 18 km per hour with respect to the train A as observed by a man standing on the ground here. Okay, so we have to go for it. and let's find out the solution for the same. So here we go for the question. Let's go for it. Two parallel rail tracks run north south. Train A moves with a speed of 54 km per hour, and train B moves south with a speed of 90 km per hour. What is the so the first we have velocity of B with respect to A. The second we have velocity of ground with respect to B. And another is velocity of a monkey running on the roof of the train. A. Against its motion with a velocity of 18 km per hour with respect to the train A, as observed by a man standing on the ground. So here for this we'll solve it out, and that we have as follows. Choose the positive direction of x-axis to be from south to north. Then VA equals to plus 54 km per hour equals to 15 meter second inverse. VB equals to minus 90 kilometer inverse equals to minus 25 meter second inverse. So here relative velocity of B with respect to A is VB minus VA, which is minus 40, and that is the train appears to be B to move the speed of 40 meters second inverse from north to south, and relative velocity of the ground with respect to B. So for A is to VB minus VA, which is equals to minus 40 meters second inverse, and for B it is 0 minus VB, which is equals to 25 meters second inverse. So in C, let the velocity of the monkey with respect to the ground Vm reduce relative velocity of the monkey with respect to A is Vma equals to Um minus Va. So for the same, that is what we have to continue here, and that what we'll have to answer it out. So we'll be solving, which is Vm minus Va equals to minus 18 km per hour, and so that it will be equals to minus 5 here minus, this is meant as 18 kilometer per hour, which is equals to minus 5 meter per second inverse. Therefore Vm equals to 15 minus 5 meter second inverse equals to 10 meter second inverse here. So here we're going to end up with this particular thing that we'll discuss here in the detail about it, which is an object is said to be in motion if its position changes with time, where the position that are of the object that can be specified with reference to the conveniently chosen origin. For motion in a straight line, the positions to the right of the origin is taken as positive and to the left as negative. In terms of path length, the path length is defined as the total length of the path inversed that traversed by an object. What we done, displacement, that is displacement is a change in position. Delta x equals to x2 minus x1, where path length is a greater or equals to the magnitude of the displacement between the same points. Where an object is said to be a uniform motion in a straight line if its displacement is equals to the in equal intervals of time, otherwise the motion is said to be a non-uniform. In the same way, an average velocity is the displacement divided by the time interval in which the displacement occurs. These are all the points which I reminded you, because all these points which we had discussed in the last classes from starting. So if you had not visited, you go ahead with that in the detail about it. But here I will just tell you about so that you will be remember about all the points. V bar equals to delta x by delta t. On an xt graph, the average velocity over a time interval of the slope of the line that connecting to the initial and the final position that is corresponding to that interval. On the same way, average speed is the ratio of the total path length traversed and corresponding time interval, where the average speed of an object is greater or equals to the magnitude of the average velocity over a given time interval. Instantaneous velocity, or simply velocity, is defined as the limit of average velocity as the time interval delta t becomes infinitesimally small. V equals to limit v tends delta t tends to 0, where limit delta t equals to tends to 0, delta x by delta t, where dx by dt. The velocity of a particular instant is equals to the slope of the tangent that drawn on a position time graph at that instant. An average acceleration is the change in velocity divided by the time interval during the change occurs, which is a bar equals to delta v by delta t, where instantaneous acceleration is being defined as the limit of the average acceleration of the time and interval at delta t that goes to 0, where a equals to limit a bar delta t tends to 0, limit delta t tends to 0, which is delta v by delta t equals to dv by dt. The acceleration of an object at a particular time in a slope of the velocity time graph at that instant of time. For uniform motion, the acceleration is 0 and xt graph is a straight line inclined to the time axis, and the vt graph is a straight line as well. In the same way, with a reference to this, we have that to be parallel time axis for the motion of uniform acceleration, and at that graph here, that is the parabolics, while the vt straight line, that is the parabolics of the time axis, where the area under the velocity time graph between t1 and t2 is equal to the displacement of the object during the interval of time. For objects in uniform accelerated rectilinear motion, the five quantities displacement x, time taken t, initial velocity v0 and final velocity v, and acceleration a is related by a set of simple equations called kinematic equations of motion. On the same way, v equals to v0 plus at, x equals to v0 t plus half at square, v square equals to v0 square plus 2a x. If the position of the object at time t equals to 0 is 0, if the particle starts at x equals to x0, and x is in the above equation is replaced by x minus x0 here. So for the same, we'll discuss the detail about it, and we go for and there are many questions that to be discussed about it, so that we'll discuss here itself, which is some of the questions I will discuss, that is, in which the following examples of motions that can the body be considered approximately of a point object. The first is a railway carriage moving without jerk between the two stations. A monkey sitting on the top of a man cycling smoothly on a circular track. A spinning cricket ball and a turns sharply on hitting the ground. Another is a tumbling beaker which has slept on the edge of the table here. Now, we'll go in depth here only, and then the rest of the question we'll discuss in the next coming class for sure. And before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than physics, we had done your reasoning, which is your verbal reasoning and the non-verbal reasoning. We are dealing with the quantitative aptitude. We are in that we had started with arithmetical ability. In that we had done 16 topics, 17 topics we have to cover up here. On the same way, coming towards, we are dealing with the CBNST, we are dealing with the TBMS. For chemistry class 11th, part 1 that we had completed, and part 2 we are dealing. In terms of physics here, which we talk about it, so here we had done chapter 1, that is a physical world, which is we had completed what is physics, scope and excitement of physics, technology, society, fundamental forces in nature, nature of physical law. Chapter 2 is your units and measurement, which is introduction of, and then the international unit of system of units, measurement of length, measurement of mass, measurement of time, accuracy, precision in instrument and errors in measurement, significant figures, dimensions of physical quantity, dimension formula and the dimensional equation, dimensional analysis and its application. Unit 3rd is a motion in a straight line, which is introduction, position, path length and the displacement, average velocity and average speed, instantaneous velocity and a speed, acceleration, kinematics equation from the uniformly accelerated motion, relative velocity as well. In unit 4, which we have to cover up here, is your motion in a plane. Then unit 5, which we'll be covering here, is unit laws of 6. Unit 5 is the laws of motion. Unit 6 is work, energy and power. Unit 7 is system and particles of rotational motion, and unit 8 is your gravitation. On the same way, we talk about for the question here, that what we have to discuss here itself for this straight line. The another question that what we'll have to discuss, I just told you, the position of a time xt graph for the two children A and B returning to their school or to their home P and Q respectively, and choose the correct entries to the bracelets below. That we'll discuss here, another one with another topic, and that has been the another classes. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Please support us as you can, and please stay tuned with us. Thank you.